Hi there and welcome back. So for this video we're going to do a permutation coding challenge. In this example, interviewer could ask us to build or construct a function that accepts one argument, and that's an array of numbers. It could be numbers, it could be characters, right? Doesn't really matter. What we need to create or a return from the function is an array of arrays, and each inner array should represent a permutation. So our return value should look something like this. Cool. You can take a moment and think about how you would solve this problem, and then we can do it together, right? So when we do permutations and think about time-space complexity, there's no way going around the slow runtime, which would be for time would be O of n factorial, right? So in this example, we see that for number 3, right, we have 6 permutations, right? Because 1 times 2 times 3 is 6. If we have the fourth element here, the number of permutations would be 24, right? And you can immediately see for each number, additional number inside an array, the number of operation would skyrocket, right? So this algorithm will be quite slow, right? And it's the same for space. It's no way around constructing this smaller than n factorial, right? Yeah, and for our solution, it's basically using, we'll do this multiple ways, right? We will definitely use recursion, and on each step of the way, we can choose either 2 or 3, and then recurse, right? So one way of solving this is using backtracking. And we'll look at another example of solving this using auxiliary buffer. These two patterns can be used in many different problems, so it's really good to know both, right? Both backtracking and using auxiliary buffer. So let's just go to code editor and implement the solution, so it's easier to just visualize, right? So let's have so the first way we will solve this is using backtracking. Another way we will be using auxiliary buffer. This, cool. So what we get is an array of numbers. So we have 1, 2, 3, and once we print the permutations, we should get all permutations back, like so. So let's define permutations array like this. What we need to first construct is results variable, which is just an array, and we'll be passing this array to our recursive function. Let's just call it rec, and we'll pass it an array. What do we pass it then? So we pass in a starting point and the results variable. And after we're done, we can just print the length of the results. So we'll see the amount or the number of permutations we got back, and let's just return results array like this. Okay, the next thing we need to do is implement this recursive function, start and result like this. And because this is recursive function, we need to take care of base case. And in our example, our base case is if start equals length of an array, and we know that we need to just append current array, like the shallow copy of array, to our results variable, and we can just return. If not, we can go into for loop for I in range, and we start with the start variable up to the last index here. Cool. What do we do now? So the first thing we need to do is swap I and start, and after we're done, we just swap it back and recurse. So I start +1, and we pass it the results variable like this. Next thing we need to do is just implement swap function, which is just a, I, and j. And in Python, we can do this in one line. So j, j and I. If your language doesn't support this, you can easily create a temporary variable like I and j, save it, because we will be overriding I, a of index I, right, with a j, and then we can just say, okay, I have j equals to temp, like this. So basically these three lines are the same as this line here, right? Cool. Let's just recap this backtracking solution. We create a results array, we recurse and pass it an array, starting position, and our results array. After we're done, we're printing the length and returning our results, which contains all the permutations. If you look at the recursive function here, we see that because it's a recursive function, we need to take care of base case, which we did here. So if the start equals to it basically passes the last index, we just append the current array's element. And of course, we need to create a copy, because if you don't, the result wouldn't be correct, right? And if it's not going over our last index, we just go into for loop and just swap the I and start and swap it back once we're done with our recursion here. Cool. So if we clear the output and run the code, we should get 6 permutations, and 1, 2, 3, 1, 3, 2. This looks good. Cool. And of course, if we put another number here, we should get 24 permutations, which we do. Cool. So we're done with our backtracking solution. So let's implement auxiliary buffer as well, just for fun. So let's just copy this, comment this out. So we need to have a permutations function like this. The thing with auxiliary buffer is the same. We have our results array, but we also need is visiting, which will hold Boolean values. Initial values will be false, so we are not visiting current index with the length of array, right? Okay, now we can pass these values of results array and is visiting to our recursive function. We also need a buffer, right? Because this is called auxiliary buffer, right? We're passing a buffer and the results variable. Oh, here, let's pass it an array like this. Once we're done, let's print a length of results and return the results like so. Okay, cool. Next thing, let's define our recursive function. Is visiting. We have a buffer and results. Cool. Our base case would be if length of a buffer is the same as length of an array. We have our permutation, and if we do have permutation, we just append buffer, copy of a buffer to our results array like this, and return. And then for I in range, so we will always go from 0 to length array like this. and we need to check if is visiting is if we are already visiting the current number, we can just continue like so. If not, we need to mark is visiting to true. Once we're done, we need to mark it back to false like this, right? Okay, and now we can, before we recurse, we need to append current number, which is a of I, to a buffer, and once we're done with the recursion, we can just pop the current number out. So it's like this, pop. Right, now we just recurse. A is visiting, buffer, and the results, like so. And I think we're done. So with permutation, we create two arrays. One is empty array, and is visiting is an array of Boolean values. We default to false. We recurse and pass both is visiting results and a buffer. And after we are done, we just print the leftover results and return results variable. Our recursive function has a base case. Whenever our buffer is full, so it's the same length of an array A, we just append the current buffer's values, copy of a buffer to our results array here. If not, we go into for loop and just continue if we're already visiting current number. If not, just mark it as true, push it into the buffer and recurse. Once we're done, we pop it and mark it as a false, which is good. Let's clear the output and run the code. And we see 24 recursions, permutations, and if we have an array of 3 numbers, we should get 6 permutations, right? Oh, we need to save it, run it, 6 permutations. Okay, cool. So this looks good. Cool. So that's it for this one, and I hope I see you guys next time. Bye.